Okay, 20 given sine, that stuff. Find the value of cosine. Okay, so again, just to maybe explain. So if we write the regular sine 2x is 2 sine x cosine x, but we want this to be 4x. Okay, so if I do this to be 2 theta, I'm just going to do 2 theta. Okay, now that's 4 theta. So this needs to be 2 theta because x is 2 theta, and this is 2 theta. So we have 2 sine 4x is 2 sine 2x cosine 2x minus 3 sine 2x equals 0. Okay, so this is 4 sine 2x cosine 2x minus 3 sine 2x. Now we have to factor out a sine 2x. We're going to have 4 cosine 2x minus 3 is 0. So we're going to have sine 2x is 0, and we're going to have 4 cosine 2x minus 3 is 0. So sine is 0 here and here. Or maybe we don't care about that actually. Cosine 2x is 3 over 4. And remember, cosine 2x is 1, nope, because what cosine squared? 2 cosine squared x minus 1, that is what that is, equals 3 over 4. So if we now solve for cosine, 3 over 4 plus 1 is 7 over 4. Divide by 2 and square root, and we are, I don't know where we are. Oh, yeah, actually we wanted cosine squared x, so it's 7 over 8. All right, given all of that, find expression for cosine squared in terms of a and b. Okay, this is very similar to what we just did. Okay, so we're going to have a 2 sine 2x cosine 2x plus b sine 2x equals 0. Factor out sine 2x. We're going to have 2a cosine 2x plus b equals 0. And we want 2a, 2 cosine squared x minus 1 plus b to be 0. So we're setting this quantity to 0 and replacing cosine 2x with its identity for cosine squared. So distributing, or not, we can just do 2 cosine squared x minus 1 is negative b over 2a. And then we need to add 1 and divide by 2. So negative b, so plussing 1, and with a denominator of 2a, that's 2a over 2a, so plus 2a, and this is over 2a, and now we divide by 2. So we have negative b plus 2a over 4a. All right, and triangle ABC, all that. Oh, AB is 9. A to C is 12. And angle B is twice the size of C. So if this is x, this is 2x. Find the cosine of C. So we have all right, so we need, I guess we use sine. So sine x over 9 equals sine 2x over 12. And we need cosine c. And I'm just going to write it up here. Cosine x, cosine c, we need 12 squared plus bc squared minus 9 squared over 2 times 12 times bc. So we have, yeah, I'm just going to keep going with this. So we've got 12 sine x equals 9 sine 2x, which is 2 sine x cosine x. So I'm just going to subtract. So we have 12 sine x minus 18 sine x cosine x equals 0. Yeah, we're not going to use that. We're just going to solve this one for cosine. So if I factor out sine x and also 6, we're going to have 2 and minus 3 cosine x equals 0. And we just care about this. So we're going to have 2 minus 3 cosine x equals 0. So cosine x is 2 over 3. The triangle ABC has an obtuse angle at B. So here's B. And we'll say BC is 10. Angle A here is x. And B is 2x. Find AC, W, in terms of cosine x. So again, we're going to use sine rule. So we have sine x over 10 equals sine 2x over AC. I'll use AC because I think I ran into trouble one time before. So cross multiplying 10 and then times 2, so 20 sine x cosine x, and then subtract that and get it equal to 0. So just, we'll do that. And then factor out a sine x. So we have AC minus 20 cosine x is 0, and we want AC in terms of cosine. So it's 20 cosine x. Now, for B, given the area of the triangle is 50 cosine x, find angle C. Okay, so we have 1/2 A, and if we're using this angle, we've got, so we're going to use A, B, sine C equals 50 cosine x, because that is the area of the triangle, and we want angle C. Okay, so we have 100 cosine x sine C minus 50 cosine x equals 0. Factor out of 50 cosine x, so that's 2 sine C minus 1. So we have 2 sine C minus 1 is 0, so sine C is 1/2. So we want the right of our finger down to be 1, which happens here. So C is 30 degrees. All right, we've got ABC is that, all that stuff. Write down the value of cosine x. Okay, very simple. Because cosine x is adjacent 5 over hypotenuse 6. Hence, find a b, this one. Oh, better not. Okay, so for b, we have... oh, wait, sorry, I missed b. Find cosine BAC. So cosine 2x is what BAC is. It's that whole thing. So we have cosine x. So we're going to do 2 cosine squared minus 1, which is 2 times 25, 50 over 36 minus 1. So that's 14 over 36. So 7 over 18. Now, hence find a b. So we've got, for c, we have cosine 2x equals adjacent over hypotenuse. Cosine 2x is 7 over 18. And that's 5 over AB. So if we cross multiply, we're going to have 7AB equals 90. And AB is going to be 90 over 7. Now, find sine B. So, sine B. So that's opposite 5 over hypotenuse, 90 over 7. So that's 35 over 90. And that's 7 over 18. All right, so for E, B, tangent of BAD. So, well, it's just tangent of x, which we can use this triangle down here to find it out. So if we do 5 squared plus DC squared equals 6 squared, that's 36 minus 25, so 11. So square root of 11 is this bit. So we have opposite over adjacent. All right, the area of the triangle shown below is that. The length of the shortest side is x, and the other side, okay. Using the formula for the area of a triangle, write down expression for sine theta. Okay, so we have A is 1/2 AB sine theta. And we have the area actually, which is 2.21. So when we multiply by 2, we're going to have 4.42 equals 3x squared sine theta. So sine theta is 4.42 over 3x squared. Okay, so now, using cosine rule, write down expression for cosine theta in terms of x. Okay, so we have cosine theta is x squared plus 3x squared minus x plus 3 squared over 2 times x times 3x. So if we simplify that, that's 10x squared minus x squared plus 6x plus 9 over 6x squared. So we're going to have 9x squared minus 6x minus 9 over 6x squared. And we can just take out a 3. So that's our final answer for B, Using your answers in part A and B show that. Okay. So this is basically cosine. It's just cosine squared plus sine squared is 1. Okay. So we would just fill that in and show that. Hence, find possible values of x. Okay, so I'd probably just graph this in the calculator, the left side and the right side, and find the intersections. So I graphed it, and when you find the intersections up here, you get that x is 1.24 or 2.94. Okay, so the corresponding values of theta in radians using your answer to part B. Okay, so if I redraw the triangle here, we're going to use, so I'll just do 2 different triangles. So 1.24 and 3 times 1.24, which is 3.72. And then 1.24 plus 3 is 4.24. So that's one triangle. And then the other one is 2.94, because theta's here. Theta. And then we have 2.94 times 3, 8.82. And I probably wouldn't just use the rounded, but whatever, I've started. And then we have 5.94 here. So we have that. Oh, I would just actually use this down here. So I would do sine inverse of 4.42 divided by 3 times 1.24 squared, right? And in radians. So, scratch that. For x is 1.24, we get that theta is 1.28. And when x is 2.94, I do sine inverse of 4.42 over 3 times 2.94 squared, and you get theta is 0.171. So when I look at the answers, this is one of the answers, but this one isn't. And actually, the correct answer is pi minus 1.28, which is the 1.86. So I think because of the ambiguous case, don't use the sine. Use the cosine theta. This. Okay? All right. So 26. Let y equals that. Given y has a maximum value, find the value of x giving the maximum value of y and the maximum value of y. So you just need to put this in the graph calculator. It gives you a parabola and you find the maximum. So when you put that in the calculator, AI is x is 5 and double I is 144. So triangle, all right, express z in terms of x. So we're given the perimeter. So we have x plus z plus 6 equals 16. And we want z to equal 10 minus x. Okay. Now, using cosine rule, so z is 10 minus x. And we want z squared in terms of x and cosine z. Okay, so Okay. So we've got z squared. What was that? b double I. We've got z squared equals whatever. X squared plus 6 squared minus 2 times x times 6 cosine z. That should be it. But x squared plus 36 minus 12x cosine z. Okay, and now z is 10 minus x squared. So they want to solve for cosine z now. All right, so this is 100 minus 20x plus x squared equals x squared plus 36 minus 12x cosine z. And we're going to solve for z. The x squareds go away. We're going to subtract 36. That's 64 minus 20x. And then we're going to divide by negative 12x. And that's cosine z. And we can factor out what goes into that. 2, 4. So that's 16 minus 5x over 4 times negative 3x. Now we'll just put the negative up top. That's 5x minus 16 over 3x, which is what they wanted. Let the area of the triangle be a, so show that a squared equals that. So for C, so a is 1/2, and we need sine z, so we're using 1/2 a b sine z, and that's 3x sine z, and they just square both sides, so that's 9x squared sine squared z. Okay. D, hence show that. Okay. So we have a squared, and we need negative 16x squared. So we need to replace cosine. We need to get rid of sine. Okay. All right, so sine squared. So sine squared z plus cosine squared z equals 1. So we're going to have 1 minus, and this is going to be 9x squared on the bottom, and just doing 5x minus 16 squared, that's 25x squared minus 160. Oh wait, no, that might be 180 actually. X plus 256. Yeah, wait, is it? No, that is 160, sorry. All right, so then we need this to be 9x squared over 9x squared. So actually those will cancel conveniently. And then we have 9x squared minus 25x squared is negative 16x squared minus 160x plus 256. And that's a squared. Is that what they wanted? Oh, plus. Oh, because it's minus this whole thing. So minus, plus, and then minus here. Yeah. Okay, hence write down the maximum area for the triangle. So this brings us back to A at the top. So the maximum, so X, so Y is A squared, isn't it? So x was definitely 5, but we had, remember, y was 144. So we're going to have 144 equals a squared. So a is actually 12. That's the answer to EI. What type of triangle is the triangle with maximum area? So that means we've got 5, 6, and 5. So it's a isosceles triangle.